So in remote method invocation, which is very much similar to RPC, we will see what are the similarity and differences. However, we are extending, let me write it, okay, we are extending this RPC for these distributed objects. Okay. So since we are talking about the objects now, so we are very much specifying that it will be object oriented. We will always have to deal with the objects. Don't think what is module or what is service, what is procedure they are being called. Now we are understanding that if at all there will be a client and there will be a server, that means there will be an object here and there will be an object here, which definitely through the process. Okay, these are two different processes. So object in process 1 and object in process 2, they will try to communicate. How? Means some of the procedures, some of the methods of this particular object can be called, can be invoked by the objects of different process. Okay. So let me repeat it. What is remote method invocation? There are two processes. So one object of a process, if is able to call or invoke the methods of a different object on a different process, then it will be called as remote method invocation. Now what I am saying is the process are different. Okay, when the process are different, then it is being called as remote method invocation. Okay, I have never said that the systems should be different and separated apart. It may be the same system or may be a different system, no problem. However, if the objects are of different processes, that is enough to say remote method invocation. However, if one object of a process calls another object of the same process, calls a method of object of the same process, in that case it will be called as local method invocation. Okay. However, if this object is calling a function from a different process, calling a method of an object of different process, then it will be called as remote method invocation. Okay. Now here basically what we are dealing with, we are dealing with the objects only. Okay, no other kind of services, only the object. Whatever service we want to provide, we will have our state, we will have our objects, and these objects will have their attributes which will represent the state of the objects, and accordingly with the object oriented system we come with encapsulation, which allows you to interact with the attributes only through the messages, only through the methods of that particular object. Okay. So here in this remote method invocation, let me tell you the similarity with what is the similarity with RPC. What is similarity with RPC? Okay. First of all, both of them support interfaces. Both support programming with interfaces. Okay. So what about the benefits that we get with the programming of interfaces, programming with interfaces? It is for both of them, for RPC also and for remote method invocation also. In both the cases we get this benefit of interfaces. Now if we see the request reply protocol that we have seen, so they both, whether it is RPC or RMI, they both have the same kind of call semantics, whether it will be, okay, let me write it, similar call semantic. Okay, as we have seen at least once, or at most once. Okay, so these call semantics, similar kind of call semantic. Similar call semantic means whatever the formula of message exchange we had, whatever way we were exchanging our messages, whatever the way we were having the having implemented our request reply protocol, they are similar. Request reply protocol is similar. Okay, because of that the call semantics are similar. Now they both, this RPC and RMI, both have similar level of transparency. Level of transparency. So what happened for RPC also and here in RMI also, that we wanted to have transparency. In case of transparency, what it means, whether we are calling a local method or a remote method, it is the procedure to call these methods are similar. Okay, so because of that we need not give extra effort to call a remote method. Okay, so that is the thing, that is the discussion on transparency. So similar level of transparency is achieved in RPC also as well as RMI also. Now we can see some differences, I should say. Let me name, it will be differences. Differences are, let me say, added advantage of this particular RMI. Added advantage of RMI. What it is? Now it is fully object oriented, right? Since it is fully object oriented, what happens? The programmers have an advantage. Okay, the programmers are able to use the full expressive power of object oriented programming, right? So what you can have here, you can see that now you can have your objects, classes, inheritance, encapsulation and whatever these things, polymorphism. These are all the things you can have, you can use it. Okay. Now, if I tell you that here now in the RPC, as I told you that when you want to call a procedure, you can send some values as send the arguments as values only. There is nothing like call by reference, right? However, here in RMI, this all objects have unique identity. Okay. You can also call it as object reference. Okay. So, because of this unique identity, you can refer these as parameters. Okay. Let me write it. You can object reference can be given. Object reference can be given as parameter. So these objects, since it is a distributed system, so including all the processes, maybe on the same node or a different node, all the objects inside these processes will have unique identification, unique reference. Okay. Because of this, these object references can be passed as parameters. Okay. You can understand that in the last case in RPC, you wanted to send the reference, but the addresses that you want to send, they were not unique for the whole system, right? Because of that, you were not able to use call by reference. However, now since we are dealing with objects, so all the objects will have unique identification, and this unique identity can be used to refer from any of the available objects. Because of this, here in this RMI, you can definitely use this call by reference. Means you can send, you can pass the reference of an object as parameter. So here what you get in RMI, you can definitely pass by value also and pass the object reference also. This is I should say your RMI is rich in parameter passing mechanism. So after seeing these things, basically we have to see the implementation of this RMI. Before that, if I have to tell some more thing, let me clear the concept of object models that you are using. Okay. So let me say something about the object model. Okay. Okay. So all the objects will have object reference. Okay, that is the unique identification of that particular object. So you would have seen in Java or maybe in any other programming language also, what happens, you create an object and you store in a variable. Okay. Okay. In this variable you store the object. So whenever you access this particular object, so suppose object 1, so you access this object with this name. Okay, so this name, this variable is actually storing the reference of the particular object, right? That is the thing. So this reference can easily be used for many other purposes. Now the object, some object will call the resources or the invoke the methods of some other objects. Okay, this can be server objects, right? So these server objects can be sometimes called as target, or they may also be called as receiver. Okay, so these objects which are target or receiver, their methods are being invoked by other objects. Okay, so here one thing that you have to understand is object reference. This reference is stored in a variable. This value can be passed as parameter also, and means passed as argument also, and you can assign this to another variable also. In many other ways this value can be used. This was a story of object reference. If I have to tell you about interfaces, okay, so these interfaces are actually, what they are, they will define define the signature of a set of methods. So in your object you will have certain attributes, along with that you will have certain methods. Okay, this will make a whole object. So you will define interface which will have a set of methods. Suppose this one, that one, two methods you are showing. These methods will actually be able to access all the attributes. Okay, so external objects may use these methods to interact with the object. Okay, they will call this method maybe with the necessary arguments, and this method can operate on these attributes of the object and produce some output. This output can be returned to the object also, right? And in between, if some error comes, it may also generate exceptions. So those exceptions can also be reported. However, in interfaces you do not specify the implementation of these methods. Okay, now where this will be implemented, these interfaces will be implemented in the class of this particular object. This particular object which has implemented or I should say the class has extended the interface. So in this class definition, somewhere you have implemented or you have specified the code related to the what you have to do in this procedure. Okay, accordingly this object has this procedure, has this method to work with, and so this method can be called by the other object. Okay, so these are the few things. However, one thing that you have to understand, that definitely classes have constructors. These interfaces do not have constructors. If I have to tell you about actions, Okay. So what it means is whenever object is invoking a method, then something is to be done. So one object is invoking a method of another object. So this invocation, because of this invocation, something is to be done. Okay. So what something is done? That something is done at the receiver side. Okay. So receiver has received the request of executing a method. So this method will be executed here for this object on the receiver side, and this execution, whatever it is executing, we are calling it as action taken. So this action is taken here, and then some reply is sent back. Okay. So this is the story of your action. Now, because of what can be the effect of this action, because of this execution, what can be the effects? The effects can be that the state of this object may be changed. State means the attribute values that it was having, this object, may be changed. Okay, let me write it. State of the object may be changed. है ना? Sometimes what may happen, this object may, okay, let me write it, that new objects may also be instantiated. New objects may be instantiated. Now, this method has instantiated new objects also, no problem. Also, this object, which is the receiver, may in turn call the methods of another object also. Okay. So because of this, you can see here a chain of invocations may arise. Okay. So these are all the consequences of action taken at the receiver side. Okay. Let me write it, that further invocation on methods of other objects. Okay, this may take place. Okay, so this is what we were seeing, that there can be a chain of action, chain of invocations due to one action. Now let me tell you about exceptions. So what happens whenever program is running? There may be certain errors. Now when the error comes, it should be reported. There is a way to handle these errors. You can call these errors as exceptions. So these sort of errors can be handled in your programs. What happens, whatever your code is, you try to handle these exceptions for them. You may be having used suppose try catch this thing है ना, try catch block, right? So whatever is whatever the statements written within the try block, they are prone to some errors, that some exceptions may occur, and these exceptions, and when you write these statements within this try block, so these exceptions, if they occur, they can be caught, and accordingly whenever these exceptions occur, what you need to do, those statements can be written here and they can be executed when these exceptions, when some exception has occurred. So because of writing such code, because of handling the exceptions, what happens, your program, your software does not crash. Okay, so whatever fatal error comes, it is caught here, and accordingly you can show some message that this particular error has occurred, and still the rest of the procedure, rest of the software keeps working. If you would have not caught this exception, you would have not caught this error, in that case, when a first error occurred, the system will crash, your software will shut down. Okay, so accordingly you need to use this try catch block, and whatever functions, whatever methods are there which are prone to errors. In that case, maybe these errors are due to the inappropriate arguments, but for any reason, if the methods are prone to errors, those methods should be defined in a way which would known to throw exceptions. So when these blocks throw the exceptions, when you are using those methods, you will have to use try catch block. So these kind of things are also there. One thing is garbage collection. You would be aware of these things. Let me remind you. So what happens in garbage collection? Your system will provide a way to free the space occupied by objects. Which objects? Such objects which are no longer in use. Okay, no longer needed. So in the system, such objects which were defined and now they are of no use, then those objects can be removed from the memory, those space can be freed up. So some programming languages, for example Java, provides this procedure as an automatic option. So it can automatically clear this memory or free the space for such objects. You call this procedure as garbage collection. Other programming language, suppose we are talking about C++. So in C++, what happens? In C++, we don't have this garbage collection kind of thing. So in that case, what you will do? Whenever you define an object, you will have to keep track always that now this is no longer used. So if it is no longer used, it should be freed up. The memory should be freed up. That is the headache of your the programmer only in C++, right? So these are something that you came to know about the object model, what happens with the objects. Now I have to tell you about the distributed objects. Okay, distributed objects. So in this distributed objects, what I was telling you is they are more or less the objects only. So what happens in an object? It will have its state, means the variables, their values, and also they will have the procedures, that means the methods that can be invoked, right? So now, okay, I was telling you about in RMI, we have to use the RMI, right? So now in distributed objects, what happens? Multiple objects are there. These are maybe in a different process, right? So whenever they are in a different process, we need to have a mechanism to access their resources. If we want to execute some of the methods of the different object, how we can do? We will have to use RMI. Okay. So one thing that we have to understand here is we are using, actually what we are using is client server architecture. Okay. So some object which is requesting to execute this procedure, they will be called as client, and these objects will be called as server. So one can be called as one object will be client, another will be server. So the client's request to invoke a method of an object is sent in a message to the server. This server is managing this object. So this invocation which comes, it will be carried out here, it will be executed. This one method of the server will be executed, and the result will be returned to the client, right? So in one message the request has come, in another message the reply will be sent. Now it is not only the case that one reply is being sent. The thing is, while action, as we have seen, one method can invoke other methods, okay, methods of another object also, maybe in the same process or maybe in a different process. So we have seen that when we call the method of an object of the same process, it will be called as local method invocation. However, if it calls a method of a remote object, means object in a different process, then it will be called as remote method invocation. So one remote method invocation may lead to another remote method invocation also, and because of that chain of invocations may also be possible. Suppose if I tell you, so here suppose this is your first invocation from here, okay, from this object A, an invocation is going to this process, this object, okay. So this object may call, means whatever the method here, may call another object here, okay, and this may in turn call another object here, no problem, and this may in turn call an object which is in a different process, okay. So this kind of things may happen. So these calls will be called as local invocation, and this will be remote invocation. Okay. So While calling, you can understand we have these information. One information is the remote object reference, okay, and another is remote interfaces. So let me repeat it what I have said. Now I can tell you